Good morning, everyone, and this is Anthony Hackett from the Aimetis Corporation on video analytics, and we're going to be talking this morning with Anthony about advanced video analytics. All right, we're going to get into the topic a little bit more. And Anthony, welcome to the program once again, and thank you for coming on the program as often as you have. We think the topic is very important. And why don't you take it away? All right, and then we'll
Great.
catch up with you as you go on.
Okay. So we've been kind of moving along this discussion of analytics from kind of understanding what is analytics, what is not analytics, using analytics with other types of devices or technologies in the field. And so now we're more in an advanced stage where we want to talk about using analytics, what to expect in the field. Using analytics is part technical and part creative, both being equal, and understanding the limitations and the new technologies that are available to people to solve issues that are at hand. So the first thing that we think about is what are the things that affect analytics? Are there limitations? And certainly there are. And the two things that affect analytics are computational, um, computing processing power, if you will, and lighting. Lighting will have an effect on the video quality. So let's start with the first, and that is computational. What I'm talking about there is horsepower, CPU, gigahertz, whatever you want to call it. Analytics, at the end of the day, are sophisticated mathematical algorithms that require a certain degree of horsepower to calculate crunch numbers and in real time deliver important alarming information. So you're going to need or you're going to require some type of processor to either at the edge inside of a camera or on a server to process and analyze the video streams that are coming in real time. So if you think about today's technology, think about the types of servers that you can buy today. AMD has 8 cores available. I mean, just a few years ago, that was not even thought of. It wasn't even an option. The best that you could get is a Pentium 4 with hyperthreading. And today, we have multiple cores available. Even the laptop that I use today has multiple cores, CPU cores that are available. So when you think about that comparative to maybe analytics at the edge, where the CPU chip isn't maybe as sophisticated as a multiple core technology, it's easy to infer that you're only going to be able to do simple things at the edge, whereas at a server-centric design will allow you to do more and more robust things with analytics. Certain types of analytics are more CPU intensive than others. For example, people counting application, which we sell as an app that you can download to an Axis camera, doesn't require a lot of CPU, and therefore it works very well at the edge. However, there's other sophisticated algorithms that we have that just require more processing than that's available on an edge device today. That'll change rapidly in the coming year or years, so that you'll see eventually everything at the edge. The second thing that we think about that factors into analytics performance is lighting conditions. Here's a real good example. If you're looking at an outdoor environment, maybe you're looking at a rail station, an outdoor rail station. Perhaps the sun is casting a shadow of people over the railroad tracks, and if we wanted to alarm on that using video analytics, we might have to understand with our analytics what is a person, what is a shadow. Now our own human eye can tell you, hey, that's a shadow, that's a person. But if you have to think about the incredible work that's done to teach systems that this is a shadow, this is a human, don't alarm on this shadow, don't alarm on the train coming through, only alarm when there's a real person. When you think about that type of technology being available today, it's actually quite remarkable. So that's one example. Another example might be if you think about a retail store, maybe cameras at the front entrance. I know your CCTV video that you produced does a really good job of um, educating the business owners on where the best placement is. But if you think about that camera being placed at the doors that open automatically, and maybe that building faces south, so the sun is going to be directly coming in all times of the day, that's really not going to give you a good image. But number two, um, you're going to deal with the noise of the light, if you will, if that makes sense. And that's definitely going to have an impact into the accuracy of the analytics. So there's a couple things to consider, obviously.
So I've got a question for you while we're here. You mentioned that computational is certainly one of the limitations on video analytics, and I kind of get part of that. But can you dig in a little bit deeper, because part of my notes are telling me that not all analytic algorithms are the same. So when would they really be different? Is it is it is the algorithm different for the capture on a retail store door opening than it is, let's say, on an airplane hangar that's supposed to detect any kind of activity moving on a runway, or right outside or right inside the hangar? Is that how the
Actually,
algorithm
both
changes?
of those examples would probably be situations where it wouldn't require a lot of horsepower. Um, all the mathematical algorithms are different. Certainly, they use different formulas, and in some cases, use the same formulas, and it's very complicated. I'm certainly not a PhD in computer vision science,
Yeah, right.
but in my experience, it's things like dwell time. So which is really difficult, and here's why. If I want to gather an object crossing a line, that really doesn't take a lot of horsepower or CPU number crunching, if you will, to see the object move, cross a line, send an alert. That's something that can be done at the edge today. When you think about somebody maybe standing still, maybe they're loitering. Loitering is something a little bit different than what I'm getting at here. I'm talking about more of a dwell scenario where somebody's actually standing still. And what that does is it tricks the system into thinking that this is this person or this vehicle or whatever we're looking at, an object, is now part of the background image that we're looking at. So you really have to teach the system with a mathematical formula to stay on and with that individual, even though they may shift from side to side, but not necessarily move their legs at all, and to stay with that person for 30 seconds, 90 seconds, or longer. Is really it's a tough problem to solve, and we've done it quite well. But it does require a lot more processing power, and therefore it's not something that you'll find on an edge device today, but in the future you will. If you're familiar with Moore's law says that things will double every year, and we've seen a nice trend in the computer industry where that's true, and obviously prices actually come down over time, which is nice. And now we're getting to this point where we're adding more cores into our systems, and we're not necessarily seeing the Moore's law double over time as fast as we thought it would. If you think about the industry 5 years ago, everyone thought that within 6 months people would be doing analytics at the edge, and it's going to revolutionize the security industry. What they found out is that the computational value that's given to them on a chip, whether it comes from ABC manufacturer or XYZ manufacturer, still has its limitations. And that'll change over time, of course, because technology is going to become more robust. So I hope that answers your question.
No, it definitely does answer my question, and it sheds a little bit more light on the math piece of it. I think I was never a math wizard, Anthony. I'm sorry. I barely got by in math. Probably did the high 70s, low 80s at best. All right. So when you start talking about these algorithms, I think a lot of the FUD starts happening in my head, saying, "Oh my God, different algorithm for what, and how does all this work, and how do you put it all together? So that's kind of why I wanted to see. But I think you laid it out pretty well. The person standing still. How does the analytics, the software, actually detect that that person isn't just a part of the wallpaper, that he is actually something that they're supposed to be focusing in on. So that kind of helps it. The people counting piece of it, is
Yeah.
and the pan
The
tilt
person
zoom as well.
standing still is always requiring some type of processing to continuously analyze that particular individual and where they're doing, what they're doing, how long. We actually have timers built into it. So it's a continuous analysis. If you think about a person crossing a line, it's just a few seconds that occurs and it's over with.
Yeah.
And
All
so
right.
that might the nice thing is that you don't have to worry about the math end, and neither do I. It's taken care of by scientists, and they make it simple for people like you and I actually to deploy this stuff. The trick becomes then, and it's a nice segue into how do you use things like object left behind, right? When analytics first kind of commercially were made available on the market, we always saw maybe ads or product sell sheets where you had the briefcase or the luggage piece left behind at an airport, and I always thought that was kind of funny because when I go to the airport, I see luggage all over the place.
Okay. So
Right?
let's take a brief time out there.